We'll proceed in summation and integral calculus. Okay, so mind-blowing discussion that we are pursuing is summation to integral calculus. Means if I have concept is can I break my problem into into different parts and make the solution. That is a scenario that we are pursuing. Okay, I have probably we will see it later. Anyway, we have seen a series summation dividing a problem into n different parts, dividing a problem into n different parts, solve part by part, and then either you add it or multiply it. It is up to you, but concept is solve the problem part by part. Okay, probably you need to add it. So this is called solving a problem, dividing into part and then sum it. Okay, in that scenario, we divide problem into different parts. I have one problem. Probably we will see the solution later. This is a very famous problem, and like there are three doors. Okay, there are three door, one door, second door, and third door, and there is a cup, some cup, or someone can say prize money. There is a prize money that is kept behind a door. Make sense? I have read this example. This is not my example. There are three doors, one door, second door, third door. Behind one of the door, prize money is kept. Okay. Now I have been given a chance to open the door or to guess in under behind which door the prize money is there. Makes sense. I just go and touch a door saying prize money is behind the door. I'm not opening it. I'm just touching the door and saying behind this door prize money is kept. Okay. Now the person who is the organizer, now he is coming and there are two doors left behind which prize money is in equal probability. Prize money to have in the door behind prize money, the prize money that is there is a prize money that is kept behind any of the door. I go and make a guess that prize money is behind this particular door. There is a door called A, B, and C. Door. If I open the door, behind the door there is prize money. So there is a prize door A, B, and C. Okay, I make a guess that B has the money. Behind the B, random guess. Behind the B has the money. Now A and C door are remaining. Okay, behind them both can be empty. There is no money, and money is behind the B only. What I am guessing, one person is coming, and then he is opening one of the door, A and C, one of the door, and he is showing that money is not behind this door. Possible? If money is behind B, then A and C both does not have the money behind the C. If B does not have money, then behind A or C money is there. So, but he is opening one of the door and saying money is not there. You can see. Now I have choice now. Can I shift to another door? Make sense? There is door A, B, and C. Someone can consider they open into three different rooms, and then behind one door money is kept. Now I make a guess that money is behind door B. Okay, or neither comes and open one of the door that one of the two remaining door, and he is showing that money is not here. Okay, now I have choice now. Now I have choice now. I can switch to either B or C. He opened A and showed there is no money here. Now I am 100% sure now that money is behind the B or money is behind the C. Now I have choice now. So should I shift to C or remain B? Because probability is same. If money is not behind A, money is behind B and C. So probability of getting money behind B or C is 1 by 2 now. Earlier probability of getting money behind any door was 1 by 3. Now it switches to 1 by 2. Now should I switch the door? Because both doors are closed now. B and C are close and money is behind one of them. That is for sure. Maximum people they won't switch it, considering that since they both carry same probability of having the wealth behind the door, so no point in switching the door. So someone should remain in the or he should switch. Now, what is the probability that he would catch the he would switch the door looking at the whatever has been showed to him. Looking at this, he should switch the door or he should remain there. In what case his probability of getting the wealth is highest? Okay. Anyway, we will see this question. So probability is a game of multiplication and addition. This is what it is called. The way I say electronics is game of resistance. At what time, what is the resistance? In that fashion, current flows. Resistance may keep varying time to time. If there is a resistor, the resistance is fixed, that is guaranteed. But if this is not a resistor, capacitor, inductor, any variable resistor is there, depending upon many factors, or if there is thermoresistor there, depending upon the temperature, resistance will change. If there is a variable resistance, the current flow will be different, depend upon the voltage. There are we will see those scenario also. Probably I'll bring a practical like Colpit oscillator is pending right now. We have seen a normal oscillator, people can watch it, capacitor oscillator or rain based alarm that we had created, and there we had a oscillator out there that was purely capacitor based oscillator. Okay, what remaining is Colpit oscillator, where we will have oscillator based on capacitor and inductor. Anyway, now someone would say that if I have an electronic circuit, then current can be in complex number also. If you see mathematics, then current in LC circuit, LCR circuit, resistor, inductor, and capacitor connected to a DC voltage also. Then if someone measure the current, current will come in complex number. It will have I factor. Means it is imaginary factor. There is nothing called imaginary. If someone measure current in the LCR circuit at any point, there is nothing will come as imaginary. Current is completely physical. There is nothing imaginary in the world. There is nothing imaginary in the world. Only thing imaginary people under say this is not real, imaginary. False thing. This is the where people run away from the mathematics, people run away from the science. Till some extent, you have real thing. Beyond that, you will get imaginary thing. There is nothing called imaginary. You are saying beyond that imaginary thing will come because you are not able to understand it. That's why you say it is imaginary. There is nothing called imaginary number or complex number and this number. People have derived current in LCR circuit as imaginary current. There are two parts in the current in LCR circuit. If someone solve the LCR circuit, he will get imaginary current also. Imaginary part of the current. There is nothing called imaginary. If someone measure the current through the ammeter, I believe, voltmeter and ammeter, ampere meter, then he will get a physical current also. There is nothing called imaginary in the world. Imaginary comes into the picture when it go beyond our brain. Then we start thinking there is something called imaginary. Okay, anyway, we will talk about it. Now we are, miss, we'll talk about this a door and prize money and this concept also. So we were talking about probability is game of and or. Probability is game of and or. If I have a coin, if I have a coin, and if I have a coin, I have two coins. I have two coins. Okay. Or I have one coin. One coin. I flip the coin. What is the probability that I'll get head? Then it is 1 by 2. If it is a fair coin. What is the probability that I'll get? What is the probability that I'll get a tail? Then a 1 by 2. Now I flip two coins. What is the probability? What is the probability that in the first coin I'll get a head, in second coin I'll get a head? What is the probability? I'm tossing two coins. Hope I really have to. I really have two coins. Okay, I really have two coins. These are two coins. Okay, one coin is bigger and one coin is smaller. But both are 1 rupee coin. When I was kid, when I was small, then these the 25 paise coin, I believe. The 25 paise coin was a stainless steel coin. 10 paise, 20 paise coin, 5 paise coin, 2 paise coin, 3 paise coin, 1 paise coin. I have seen those used to be aluminium coin. 25 paisa coin used to be a stainless steel coin. 50 paisa coin, a stainless steel coin. 25 paisa coin was far better than 1 rupee coin nowadays. And India is becoming a powerful country. Anyway, now I have two coins, both are 1 rupee coin. If I throw it and then I see what is the probability that I get head. Okay, I got which one is head and which one is tail. I really forgotten. I never for a long time I never did. Okay, head. Actually, I got head. This is head only. That is the Ashok Chakra emblem. That is head, I believe. So I had got head. Pardon me if that is tail. I don't remember which one is head and which one is tail. Okay, what is the probability that I get a head in the first coin and I get a head in the second coin? What is the probability that you get a head? What is your statement? Statement is I get a head in first coin and and I get a head in second coin. What is the probability that get a head in first coin? I get tail head in another coin. First coin head probability is 1 by 2. Getting head or tail probability is 1 by 2. What is the probability of getting head in another coin? That is 1 by 2. Okay, both are independent. This coin is completely different and it is run on its own space. That is called process address space if you see the software. Every program runs in its own address space. It is something like two laptops are running and I am running two different programs on two different one single same program on two different laptops. Okay, what is the probability that in one program output will be like this and in another computer both are unrelated to each other? If they are unrelated to each other, it is also called independent. They are unrelated to each other. In that sense, the probability of getting head here is 1 by 2 and it is 1 by 2. If I say both head and head, tell me how much it will be. If I say head and head, then it will be 1 by 2 into 1 by 2. What is the probability that first is head? Probability that first is head or head. Hope. Okay, doesn't make much sense. Okay, consider that case that we have there is a two statement. One is called and. I have one event and I have another event. I have one event and another event. If I want two events to happen together, like one is head and one is head, if both are independent, then it will be multiplication. Okay, if two events I want to happen in a mutual exclusive, there are two terms. Okay, I'll demonstrate later. I'll bring better example. There are two things in the probability. One is called and two events if I want to sit together, like one coin is head and one coin is head. Two events I want to see together. Then typically it will fall in multiplication area. Two events I want to see in a or fashion, not in an and fashion. Or fashion. Two events in an or fashion. Either this or this. Okay. Typically it falls in summation or falls in summation and falls in multiplication. Okay, if I say if I have a event A and event B, I want to see both together, A and B. And if it is really equal to A into B, then this is called independent. If it happens so, otherwise, if I say A and B, what is probability of A and B? What is probability of A and B? Okay, I'll give another example. I'll give another example. Okay, consider there is a country called Switzerland. There is a country called Switzerland. In Switzerland, there would be people who are native German. They speak German language. There would be people who are native French. I believe Switzerland it interface with the France also. So Switzerland or Italy, certainly it faces Italy, I believe, or French. Consider it interface French. There are native French people in Switzerland and there are native German people in the Switzerland. Okay, what is the probability? What is the probability that what is the probability of if I choose a person if I choose a person, then what is the probability? Hope, again I'm confusing something. Okay, the concept is that what is the probability that he is, hope. Okay, we will take it later. Okay, better we will come, I'll come to this addition and multiplication. Addition comes as OR relationship, or. This is also called mutual exclusive, that is addition. Multiplication typically come in AND relationship where it is called independence factor and two events they should happen together. Two events unrelated happen together. Like in one coin, I say what is the probability that this coin has a tail. If I toss two coins together, this coin has tail and and this coin has head. What is the probability? Okay, then if I say like this, then if I get this, okay, if I get this, okay, I believe I'll go with the Switzerland. Now I have a person, and then I select that person. What is the probability that person is German? In Switzerland, that person is German. What is the population of German people in Switzerland? Consider it is 1 by 10. Then I touch another person, and what is the probability that another person is French? What is the French population in speaking people in Switzerland? Consider, I'm not giving actual data. Consider it is 1 by 20 and one is 1 by 10. What is the probability that I pick a person and he is German speaking, and I pick another person and he is French speaking? What is probability like that? So first person if I pick and he is German speaking, probability is 1 by 10. And person if I pick another person, he is French speaking, then he is 1 by 20. But I want and if I pick one person, guaranteed that he is German speaking, guaranteed, and again guaranteed that another person I pick, he speak French in Switzerland, and then it will be 1 by 10 into 1 by 20. Okay, this is called multiplication. I believe it will come as or, that I'm not sure, we will see it. If I pick a person and he is German, he is German speaking in Switzerland, probability is 1 by 10. Or, or, or I pick another person, he is French speaking. One of them is alright. Any one of them is alright. If I pick a person, he is German speaking person. If it is one, then it is very good. Or I pick another person, he speaks French. What is the probability? Probably it will be addition. We'll try here. I pick a coin, and what is the probability that it is head? Or 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 I pick another coin. What is the probability that it is head? One of them. Okay, this coin this coin. If I toss it, then I get a head. Okay, if I don't get a head, or means if I and means first is one and second is one. Okay, I get head and I get a head. First is one and then second is one. Both one should be there. Okay, it is like head and head out of all the permutation combination. I see there are four permutation and combination. Finally it will come to sample space only, and out of four I have only one where head and head is there. Certainly it will be 1 by 2 into 1 by 2. Okay, now my question is, I toss a coin and it is head. It is head. Okay, it is head. Okay, or another means I toss 2 coins. It first one is head or second one is head. Anything is all right. Now I have, if I see the sample space, then there are four sample space. Or if I take 1 coin, just take 1 coin. If I toss it, then I say it is head or tail. It is head or tail. There are only two in sample space, head and tail. It is head or tail. It will be probability will be addition. 1 by 2 plus 1 by 2. That will be 1. If it is if I toss, it should be head and tail. Statement is wrong because it can be only one thing. It can be head or tail. 1 by 2 plus 1 by 2 or will go in addition. I have 2 coin now. Okay. Now first I say it should be head or next coin should be head. Okay, if I say first coin should be head or next coin should be head. Okay, now someone can think about it. What will be sample space? If first coin is head, the next coin can be head or tail. That is all right for him because if it is first is head, doesn't matter what is the next one. Makes sense? Or next coin is head, then doesn't matter what the first coin is. Makes sense? Okay, what are the sample space? Tail, tail, tail is the sample space. One is okay. One is head, and one is head, tail, tail, head. There are four in sample space. Okay, if I say first coin should be head, first coin should be head. Okay, in that fashion, I don't care the other coin at all. It can be head or tail, doesn't matter. It will work. Head or head. So if it is head is coming, doesn't matter what the second coin is. Probability of getting this first head, first head would be I believe how much it will be. It will be 1 by 2 into 1. I believe it will be 1 by 2. First is head, then it will be head, 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 tail. 2 by 4, it will be 1 by 2. Okay, first head, if I get first head, it will be 1 by 2. Doesn't matter. Or next head. Okay, this is not head, this came as tail. Okay, then I go and see another one. Then in that case, it should be head. Okay, we will work on it. Certainly, it is not the multiplication. This fall under or an and relationship or and relationship if someone understand. Okay, 1 by 2 plus 1 by 2, if I say in that fashion, it will be 1. Means in that fashion, this should be 1. If they are mutually exclusive, this we'll talk about. Okay, we are discussing that how I can divide a problem into n different parts. How I can divide a problem into n different parts so that I can get the solution quickly. How I can divide problem into n different parts and I get the solution quickly. Okay, in that fashion, consider I have n number of coins. This is 2 coins. Consider I have n number of coins and I have C amount of dollar or rupee or euro or pound or ruble or yuan or any other currency. I have C amount of a currency, a particular currency. Now I have n number of coins. I have n number of coins. If I have n number of coins, I throw the coin. Okay. Now, if I see there are k heads are appearing, now I check coin by coin. I have n number of coin and I throw it and then I toss it together. I see n number of coin. I check coin by coin. If it is head, my money get doubles. If it is head, then my money get double. If I see tail, my money becomes half. Consider I see three head continuous, then I see the tail. Okay, then if I have C amount of money, it will become 2C from the first head. Second head, it become 4C, double of whatever right now. Then if I see next head, it become 8C. Okay, if I see the tail, then it will become half of the 8C. It will become 4. If I see tail again, it will become 2C. If I see tail again, it will become C. If it becomes tail again, my money will get half again, C by 2. If I see tail again, it becomes C by 4. If I see tail again, I will see C by 8. Okay. Now question is arising that what is the expectation after I make a toss? I make a toss and I have of n coin and I have C amount of money. Then what is the money that I can expect after this toss? Average way. That is the question. I believe it is all right. If I have n number of coins, this is two coins I have. I have one more. Okay, I have three coins now. So I have one coin, I have two coins, and I have third coin. So there are three coins. There are three coins in my hand. Consider there are n number of coins in my hand, and I throw the coin, and now I start counting, seeing the each coin by coin. If coin comes head, my C amount of money, dollar, it becomes multiplied by 2. Then if I see head again, it multiplied by 2. So first time it will become 2C, C will become 2C. Next time C would become 4C. Next time 4C would become 8C. Next time 8C would become 16C. When I see tail, it will become half. I see tail, it will become half. Okay, at the end, on an average, what will be the amount that will remain with me? Will it grow, it will shrink, or it will be same? Anyone would say it will be same. Because the chance of coin is fair. The chance of getting head or tail is same. In that fashion, on an average, money that I will have will be same. Suppose someone is challenging me. Okay, try it. What is the guarantee that should I play the game or not? Should I lose the money? Should I gain the money? Or money will be like that only. Means today I am playing with that person this game, then probably I lose the money. Tomorrow I am playing the game with the person, probably I'll gain the money. Next day I am playing the person. After n number of after some try, some 10 days or 20 days, this is average. What should I expect that how much money I'll gain or lose or whatsoever? That is the game. Okay, in that fashion, now question arising is how many heads we are getting and how many tails we are getting on average. I believe I'll rephrase this question, a question or solution. Okay, so consider that I am getting, when someone throw it, I get one head, I get one head and n minus one tail, n coins are there. I get one head and n number my n minus one tail. Okay, first I can say I don't get head at all. All n coins are tail. Then what will happen to my money? Then it will be C. It will be C. C into, consider the head probability is P, and tail probability is 1 minus P. It is a fair coin, then P equal to 1 by 2. Head probability is P and tail probability is 1 minus P. Okay, then if I toss a coin number of head, how much I can expect? If number of head is 2, number of head is 2, consider there is n number of coin and number of head is 2, and consider n number of coin instead of n number of coin, I am saying there are 3 number of coin. There are actually 3 number of coin. Okay, now I have 2 head and 1 tail. Just 2 head and 1 tail. Okay, what is the probability of getting 2 head? Getting 1 head, if I flip 1 coin, getting head or tail probability is P. Getting head probability is P. Typically it is 1 by 2. Getting head probability is P. Getting tail probability is 1 minus P. What is the probability of getting 2 head? Then it will be P into P, the way we talk, and relationship. That is what something I talked in concrete manner. So if I say 2 coin, one is head and another is head, then getting head is 1 by 2 into 1 by 2, and then another is tail. then getting tail is again 1 by 2, or P into 1 minus P, that is the probability of tail. Getting head and tail, the probability is P into 1 minus P. Make sense? Okay, it will be P square 1 minus P to the power 1. Or if there are n coins, it will be P square 1 minus P to the power n minus 2, if I am talking about two heads. Okay, so getting the probability of getting two head and rest of the coin as tail, this will be P to the power 2 into 1 minus P to the power n minus 2. Okay, now someone will say, what is guarantee that first two coin will be head? Means the way you are saying two coins should be head, right? First two coin will be head, this is what you are talking. But whatever the assumption you are making, that is satisfied when you have first coin and third coin as head and middle coin is tail. That is also okay to you, right? Yes. I want two head. Then my problem is satisfied. Okay, there can be chance that last two are head. It is looks like that we have to talk about combination now. In one combination, there are three combination now. If there are three coins, first combination is first two coin are head and third is tail. Next combination is first and third is head and middle one is tail. Next combination is first is tail and next two are head. I'm not shuffling it. There can be other combination also. If I say first two are head, then if I exchange it, then I see as a different thing that I am not taking. This is a pure combination, not permutation. Okay, in that fashion, for one combination, the probability is 1 by p to the power 2, 1 minus p to the power n minus 2. But there are three probability. Okay, if I talk about two head out of n, then it will be nc2 probability. In that manner, we arrange it. So net probability of getting two head out of n coin is nc2, because two head will appear at any position in n coin. First two, the next two, the next two, the next two, or first head and last head, first head and second last head, first and third last as head. So there will be NC2 combination. NC2, 2 to the power K, 2 to the power, I'm sorry, P to the power 2, 1 minus P to the power N minus 2. This is typically called binomial distribution. Binomial distribution. This explanation why binomial distribution is NCK, consider, or NCX, where X is number of head we are trying. NCX p to the power x 1 minus p to the power n minus x. Why this is like that? No one explain it. Actually, we try in one go and then we find it is p to getting x head is p to the power x in bracket 1 minus p to the power n minus x. Now for that we have how many combination we have like this, that NCX. So net probability of getting x head is NCX p to the power x 1 minus p to the power 1 minus x. If this is the probability of getting head, if this is the probability of getting head, okay, then we have to multiply this with 2. I believe it is all right. Okay, we have to multiply it with 2. Means in that fashion, 2 will appear this many times. I mean, I have to multiply with the 2, right? Means I'm sorry, I have C amount of dollar or rupee. Okay, it would become double if it would become double if there is one head I find. Consider what is the probability that I get x number of head. If I get x number of head, then I have to multiply with the 2 into c I keep outside. If x number of head is appearing, then I have to multiply it with 2. Makes sense? Plus plus if x number of tail is coming, then I have to multiply with 1 by 2. This is what the amount of c will be. Means how much the c will be after it. So okay, the c, what we see the c is, if I say that number of head, if I say number of head is x, then it will be ncx p to the power x 1 minus p to the power n minus x into 2 into c. That is the amount I'll see after x number of head. Okay, okay. If that is the case, after x number of head, if I see that much amount, what will I get if I see x number of tail? Then it is c into 1 by 2 ncx p to the power n minus x 1 minus p to the power x. Okay, now this is the scenario that I see when I have n number of head or n number of tail. This much money I'll have. Now I have to sum it for all number of head. This is what the average expectation is. Consider that head is 0. Consider head is 1. Consider head is 2. Consider head is 3. Consider head is n. Okay, similarly, I see tail as 0, tail as 1, tail as 2, tail as 3, tail as n. Then what will be if I have one head, then it will be 2 into 1 and rest of tail, that will be 2 into nc1 p to the power 1 1 minus p to the power n minus 1. That will be the new money that I will have for with one head. What about with two head? Because I'm trying to calculate the average with two head. Okay, with two head, it will be n in c into 2 nc2 p to the power x p to the power 2 1 minus p to the power n minus 2. With three head, okay, I am trying to average the head. How many head on average we are getting? What are you talking about? What is average head? Anyone would ask. These are not very simple questions. Anyone would ask, what are you talking about number of head? Okay, I have always given this example. Now in a class, I have n number of students. Each student is securing a mark out of 1 to 10 or 0 to 10. Now a student is securing a mark. Okay, what is the average mark of a class? If I say, what is the average marks of a class? Then one student by student I call. In a class, there are n number of students are sitting. Recently, there was one examination, and in examination, the marks was 0 to 10. Now I am asked to calculate the average marks of this class. Okay, I call student by student. One student comes, I ask his mark, and I note it down. Similarly, for n number of students, I noted down the marks, and then I add it and divide by n. I get the average marks of this class. This is what we are trying. This is what we are trying. We are trying that if I throw a coin, then I get amount of head. Okay, if I throw a n coin again, I get the amount of head. If I throw a coin, I get the amount of head. What is the expectation of number of head I get? Makes sense? What is the expected value of the head I get? Okay, this is what we try. If I know the expected value of a head, then I can multiply it by 2, and I can say this is the expectation of the currency to become double. Then I check what is the expectation for the tail every time. Then I multiply it by number of tail I expect that it will come, multiply it by 1 by 2, and then multiply by c. This much is the amount I can see, it will become half. Okay, then I add it and then I say that this is what is the expected value after the, if I do repeated through. Okay, if I take the class example again, then I add all the students' marks and divide by n. That is called average mark. There is another way to calculate it. Now draw a graph. Right. This we are doing student by student. Let's take marks by marks. What is marks by marks? I can call a student only, right? I cannot call marks. Okay. Let's this consider this is an axis called marks axis. Against each mark, draw a vertical. Okay. Against mark 2, just see how many students are there. Against marks 3, see how many students are there. Again, marks 3, consider there are k students are there who have got marks 3. Then we draw a vertical graph saying it is k by n. The probability of getting a marks 3 number of a student is k by n. Okay, like that. Now, what is the average mark? Take 1 mark and see how many students are there. Probability. If students are 4, then the height will be 4 by n. Now we have 1 mark, 1 into 4 by n. Makes sense? If I have 2 marks, then see how many students are there. Students are 10. Then 4 into 10 by n, where height is probability. Now marks is 5. How many students got 5 marks? 20. Then 5 into 20 by n. Like that, if you add, then straightforward you get the average mark. Similarly, we are trying to get the average number of head. Okay, if it is one head, if I get one head, what is probability of getting one head? If I multiply one, if I see one head, then what is probability of getting one head? So 1 into probability of getting one head plus, if I say I get two head, if I see two head, what if I get two head, what is probability of getting two head plus, if I see three heads, what is probability of getting, what is net three head I am getting? Then 3 into number of time, what is the probability of getting 3? The way each marks how many students are there. What is the probability of a student getting marks 3? 3 into probability of a student. If I say what is the probability of getting head out of n, okay, then that much, that probability, that is the height, into 1. Okay, in that fashion we will rephrase this solution. So getting probability of one head is nc1, or getting probability of getting zero head is nc0, p to the power 0, 1 minus p to the power 1 minus p to the power n minus 0. Make sense? Okay, now I have to add for all the head. Okay, what is the expected value of a head here? That is 0 into nc0 p to the power 0, 1 minus p to the power n, plus 1 into nc1 p to the power 1, 1 minus p to the power n minus 1, plus 2, 2 into nc2 p to the power t, 1 minus p to the power n minus 2. It would become now summation I equal to 0 to n, or summation x equal to 0 to n, x ncx p to the power x, 1 minus p to the power n minus x. This is the average expectation of getting how many heads we will get. That is summation x equal to 0 to n x into ncx, that is the probability part, ncx p to the power x, 1 minus p to the power n minus x. This is the expectation number of head we will get, into 2 into c. This is the amount that will get doubled, plus n in, sorry, c into 1 by 2. This is tail, because tail it will become 1 by 2. C into 1 by 2, summation x equal to 0 to n x ncx p to the power n minus x, 1 minus p to the power x. This is what is the money that we are getting. This is called full phrase. Now if the repeated summation what we are taking, if I convert into integration somehow, then it is full phrase integration, and this is extremely difficult to solve. Okay, we are talking about breaking our problem into n different parts. We're breaking our problem into n different parts. What we are seeing here, if I have taken n number of coins, each coin are different. They have different probability distribution. And if one coin head is coming and another coin head is coming, this is mere a chance one. I cannot say that if first is tail, then getting tail on the another coin is higher probability than getting head. then they are dependent upon each other. This is called dependency and independency. Dependency and independence. Getting tail on another coin provided there is a head on the first coin. Getting head on the another coin, getting head. I'll rephrase this. Getting tail on second coin when there is a head on first coin. What is the probability? Getting head on the first coin when there is a head in the first. Getting head on the second coin when head is on the first. If first coin is head, I toss the coin and first coin is head. What is the probability that next coin will be tail? That is one thing. What is the probability that next coin will be head? That is another thing. Now the first coin is tail. What is the probability that next coin will be tail? What is the probability that next coin will be head? All are same. Doesn't matter what the first coin is showing. This is called independence. Those coin outcome is independent to each other. If it is independent to each other, I break the problem into n different parts. We were trying to tackle the problem as n coin, not take coin by coin. Because I know if I want something together, I have to AND it. If I want something together, I have to AND it. This is what I know. Okay. Now in that fashion, take one coin, single coin. Then we will work for all other coins. Okay. Now take one coin. If it is one coin, what is the money what is the average probability of head and tail? If it is one coin, if it is one coin, then number of toss I do, then n nc1. If I want one head, so that my money. If I want zero head, then money will not get doubled. I want money to be doubled. So I want that coin to be head. If I want coin to be head, then I toss one time. Then I see it is head or not. That should be head. Then it should be NC1, that is gone. P to the power 1, P to the power 1, 1 minus P to the power 0. It will come as P into 2 into C, 2P, C keep outside, 2P, 2P means the probability, I'm sorry, the expectation, the average value to get one head is P, that is 1 by 2. P into 2. So my amount will become 2P. What is the probability, average probability of getting tail if I have one coin? Then it will be NC1, NC1, 1C1, that is gone. P to the power 1 minus 0, because it should be tail, and 1 minus P to the power 1. I believe it is all right. Multiplied by 1 by 2. So average tail probability expectation when one coin is there, it will be 1 minus P to the power 1. 1 minus P. 1 minus P by 1 by 2. Now we have to add both so that we will see what we will get. So we have now 2P plus 1 by 2, 1 minus P. Okay, this is what the scenario, the way we did in bigger thing. Now we are doing same thing in a smaller fashion. Add it. It will become 2P plus 1 by 2 minus P by 2. 3P by 2 plus 1 by 2. This is what I think. So. 3P by 2 plus 1 by 2 into C dollar. Okay, into C dollar. So keep the C outside. Okay. Now this, if this is the money value, this is the multiplication of the money value for the one coin. Now I have to do with the all coin where relationship is and. Okay, this is the money when it is head or tail, that is 3P by 2 plus 1 by 2. If it is n coin, then I have to multiply n time, not add n time, because this is and relationship. Okay, so it will become 3P by 2 plus 1 to the power n. That many times my C dollar will get multiplied. Let's P equal to 1 by 2. Then it will be 3 by 2 into 1 by 2. 3 by 4. I believe it will be 2P, 2P minus, I'm sorry, 2P minus okay, what it was, 1, 2, I'm sorry, it is, earlier it was 2p minus p by 2. 2p, it became, I believe it is, or oh, I'll try again. Okay, so the real scenario for one coin, the average number of head and tail what we added, head was 2p, 2p, p into 2, and there it was 1 by 2, it becomes half, 1 by 2 into 1 minus p, 1 by 2 minus p by 2, 2p minus p by 2, 2 to 4p minus p, 3p by 2. So I am saying right, 3p by 2 plus 1 by 2, 3p by 2 plus 1 by 2. So it will become, if I say p is 1 by 2, then it will become 3 by 4. 3p by 2, it will become 3 by 4 plus, hop, 3, okay, it will become 3 by 2, 3 by 2 p. Okay, if I see the one term only, 3 into 3 by 4, it will become 3 by 4 plus 1 by 2 plus 1 by 2. Then how much? 5 by 4. It will become 5 by 4. If p is 1 by 2, it is a fair coin, then the multiplication factor for the C dollar is 5 by 4. Can someone imagine? When I know that my coin can be head or tail, it can be half probability is head and half probability is tail. If I toss a coin in that fashion, it can be head or it can be tail, half probability. If it is head, it become double, and it is tail, it become half. That is also same thing. So it should come as one only, means the expectation of the money getting doubled or half, but it is becoming 3p by 3p by 2 plus 1 by 2. It is becoming 3 by 4 plus 1 by 2 if it is 1 by 2. P is 1 by 2. It is becoming 5 by 4. Means there is a guarantee that my money will increase in this probability. People would not consider this into the multiplied by n time, because we have calculated for one time. This is called summation, and summation, this is the breaking the summation, breaking the problem into different parts, and then either you add it or multiply it. I am multiplying it because we are expecting and relationship between each point. This is what we saw earlier. If it is 4 head, then 1 head, that is probability is p, then p into p into p into p to the power 4. This is what we started the calculation is. Same thing we will carry on to get the multiplication factor for the one coin is 3p by 2 plus 1 by 2, where p can be anything. If it is completely biased coin, it will always be head, always be head only, always be head. It is a purely biased coin. Then it is 3 by 2, 3 by 2, where p is probability of head, 3 by 2 plus 1 by 2. How much it will be? It will be 4 by 2. Okay, it will keep, that is 2. It will keep doubling only. With each toss, it will keep, means with each coin. Now, not I am making toss one by one. I am throwing coin in together. With each coin, if with each coin, the chance of doubling the money is one only. Means each coin we will double the money if it will appear only head. So this is completely all right. Okay, if it is biased coin and getting tail is probability tail is 1. If tail is 1, then p is 0. P is 0. If p is 0, it is 3p by 2, where p is 0 and 1 minus p is 1. So 3p by 2. In that sense, it will remain as 1 by 2. What is 1 by 2? 1 by 2 is getting half. So with each coin, if I throw, with each coin, it will be half. It will become getting half. Because if I throw n number of coins, then each coin I'm checking. If you are head, then double. If you are tail, then half. Then next coin, when I throw it. So if it is a biased coin and it is always head, then double. If it is a biased coin, it is always tail, then half. If it is not a biased coin and it is p, head is p can be anything between 0 and 1. If it is half, then getting one with one coin, my money will become 5 by 4 times. Not 1. People would have expected 1. It will not change. Okay, but it is 5 by 4. Okay, we divide the problem and then we see the coin by coin. It is AND relationship and it will be 3 by 2p plus 1 to the power n times c. Well, we will get them, we will gain the money anyway. What is calculus here? The calculus here is that the what is how much we are getting. Now we are getting not the sigma sign. Sigma sign is for addition. We are getting multiplication sign. And multiplication sign we have 3 by 2p plus 1, okay, to the power n. If it was a summation, but this also falls in breaking the problem into n different parts and solving it. Okay, people have option to go with the first one, that we tried a bulk. In a bulk, we try to solve the problem. So there is someone has chance, probably there is a repeated summation and someone has chance. Anyway, this is the not the complete integral to summation to integral, but this give a hint that how our problem is getting solved when we break into n different parts. We will take more example on this. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.